fill it in, use a pen or something. I mean, if it's NR at the top, you can use whatever you want. I'll understand what happened there. So anyways, when you have one of these, it's not a frequency table, right? These are raw scores. And what are they? It's the lifespan in years. So that means that all your units should be in years, right? Determine the mean and the standard deviation of this set. So you would use one variable stats, and it's simply L1, okay, L1 there. And your mean is 2.51 years. Your standard deviation is 0.56 years. And your that's all it's asking for. But if you have n, it's always a good check to make sure that you're doing this right. There are 7 values and then 5 rows, so that should be 35. So that's your mean and standard deviation. If you didn't get that right, go -1. And so here we're gonna honor what you got up here. So I'm gonna look at the steps, right? So what you should have is in the middle, you should have the 2.51. That should be your middle value. This is all years. To be honest, in this case, I don't really care about labels and all that as much as I would if you have to draw a normal curve. It's a frequency line that we're making. Okay, so we're going 1, 2, 3 to the right, and we're going to have 3 bins to the left. Remember, this is supposed to be, we want to see if there's a bell curve. That's what we're trying to do. Don't draw the bell curve, but that's what's happening here. So you go up by a standard deviation every time. So this would be 307. This would be 3.63. 307, sorry. Doesn't look like a 7. And this will be 4.19. And then we go to the left. This should be 1.95. And this should be 1.39. And this should be 0.83. You did that right. If you have these values, okay, then I would expect you to have these numbers down here. If you thought, you know what, maybe I have to fill in this last value, that it doesn't hurt. This will be a 4th standard deviation. And if you go all the way to the left, it should be 0.27. I don't really care about those. If you do 3 to either side, you have enough information. Okay, and then you have to sort this. So you make sure you sort L1. And then go through your values on your calculator and put them in the correct interval, right? So if you did this right, there's 1 value in here. There are 5 values in here. Here we've got 13, so that's 5, 10, and another 3, that's 13. Here we've got 8. And then we've got 7. Here, 1, 2, 3, 4, 5, 6, 7, and you've got 1 in here. So if you put numbers down, that's 1, 5, 13, 8, 7, and 1. So if you, I would kind of, usually what I'm looking at is, are these values correct? You get 1 mark already just for the values. And I will get rid of the half here and make this worth 2 marks, because I would also say that the values that you put in the bin should also be correct. That's another full mark for that. So 2 marks for this. Is data normally distributed? Show your work. So we're checking, right, plus or minus 1 standard deviation. And it's every time we're checking how many of the 35 values that we're considering are falling within 1 standard deviation. So this is your mean. So you would include the 13, everything from here to here, right? So 13 and 8. So that would be 21 over 35. That ends up being 60%. Versus supposed to be 68, right? So it fails, right? So you could say data is not normally distributed And why is that? If I ask you for why, it does not follow the 68, 95, 99.7 rule. Okay, that's the reason. You can stop there. If you continued, there's nothing wrong with it. But if you consider 2 standard deviations, that'd be from here all the way to there. So it's basically everything except for the 2 tail, right? So this is 33 over 35, and that would be 94% versus 95. So this actually does pass the test, the 2 standard deviation check. 3 standard deviations, you're going to have everything in there. 35 over 35, that's 100% versus 99.7. That usually passes. This will usually pass every single time. It's going to be either the first one or the second one where data is, or it's going to fail the test. Okay. So 1 mark, I would say 1 mark for having the correct check, and 1 mark for telling me whether or not data is normally distributed. And I would normally look for this statement here as well. Like, does not follow the rule, right? The empirical rule. So far, 6, sorry. I'm going to go up here. To make this easier, we're going to go back to A and change that to 2 as well. So I'll just give you 1 mark for each. Okay, that will make our tally easier. So let's go all the way to question 2 now. There's a salaries distribution. Find the mean and standard deviation. So I'm just reminding you, this is a frequency table, and it's dealing with money. Okay, so that's going to be, those are the units that everything should accompany. So this, we need the midpoints. And the midpoints would be 22,500, 27,500, 32,500, 37,500, 42,500, 47,500, 52,500, and 57,500. Okay? So if you have that, I give you a mark for the midpoints. And then to find the mean, standard deviation, and so forth, we need to have this into L1 and this in L2. So this will be a 1 variable stats, L1, comma, L2. And to find the mean, you get 27,391.30. That's the average income. Standard deviation is 7241.12. And N is 184. What would N be in this case? Number of workers, number of salaries. Yeah. Salaries, workers, just, yeah, context, right? So this is 1, and I'll just give you another 1 for all of this. If you did not use L1 and L2, you're getting this. You're getting 40,000 for your mean, and the standard deviation will be 11,456.44. And this is the greatest indicator that you did something wrong. N is equal to 8. Like, you're literally just counting. It's really just counting these 8 salaries. It's thinking there's just these 8 because you didn't feed it the frequency, right? So this will be wrong. Okay, the wrong way of doing it. Forgot L2 in there. So 2 marks as well for this. So 2, 4, 6, 8 for this page. This is self-evaluation, guys, and at the same time, it's a lesson, right? So it gives you a little bit of a guide on how you're doing. Backside. Certain brand of flat screen TVs has a life expectancy of 10 years, a standard deviation of 1.15. Use technology, right? So don't be drawing your curve and getting the numbers. Just use technology, which means Normalcdf inverse norm. That's what I'm asking you to use and show all entries. Determine the probability that TV will last less than 7.5 years. It's asking for probability, and we want less than 7.5 years. So you just, come on, you just use a very small number here, right? All the way up to 7.5 years, and then mean and standard deviation. Multiply that by 100, of course, and you get 1.49% of TVs. 1.49% is fine. What percent of TVs last less than 9 but more than 11.6? I will go this way. 1 minus normal CDF, and we're going to remove anything in between 9 and 11.6. So basically, right, this is 9 here somewhere, and this is 11.6. These are good. Okay. Actually, no, I'm not going to use good here. I'm interested. This is all I'm going to focus on. I'm interested in this. I want to know the tails, right? Basically. So if I go 1 minus this, right? This part right here gives me the, not necessarily the middle, but the in-between. So when I do that, I go 1 minus 0.7257. Like this is what I get out of normal CDF there. So if you want the tails here, that is 0.2743 or 27.43% of TVs. Okay. So regardless of how you did it, the reason you need there's 2 marks involved. 1 mark for me would be to find this part, right? Just that normal CDF between 9 and 11.7. And another mark is the subtracting part. If you did it the other way, if you found this and added, right? That is the second mark. The addition of the 2 is the second mark. And then I give you 1 mark for finding each of these individually. Okay? About 32% of TVs last less than this many years. This is inverse norm territory. Okay? 32, so you have to make your bell curve here, if I would suggest. And if you put the mark here, right, you're trying to find the number of years that would have 32% of TVs lasting fewer than that many years. So you're getting the left side. This is 1.15. So when you get inverse norm, you get 9.46 years. Okay. Either fill it in up there in the blank or just state it here. The top 12% last longer. So here, top 12, they're giving you this 12% here. You want this part, which is 88%. So I'm going to give you 2 marks. 1 mark for using inverse norm, and another mark for using 88% or 0.88. So that would be 11.35 years. So 1 mark for the 0.88 and 1 mark for using inverse norm and getting that value. If you use 0.12, you get 1 out of 2 here if you use inverse norm. Okay? If 20,000 TV, or sorry, 200,000, right? 200,000 have been produced, how many would last longer than this? This is the short version of this question. You take 200,000, you multiply it by normal CDF of anything that is greater than that. So 12.35 all the way to just a large number in there, 10, 1.15. So in a sense, you find the percentage of TVs that last longer than this, and then you multiply that by 200,000. Okay, so I just do it all in one step here. So this part is 0.0205 and then some. I keep it all in my calculator if I'm in the process. So that ends up being approximately 4,100 TVs will last longer than 12.35 years. And if you're wondering, if you want to do a little bell curve, right, 12.35 maybe here, and so there's a little bit of a tail here of TVs that last longer, and so that is this part. Okay, so that's, you multiply that if it's wanting the actual number of TVs. So if I give you a number produced, right, that means that you have to do two steps. Find the percentage, keep it as a decimal, of course, then multiply it by the number that has been produced. At the middle, 50% of TVs last between this and this many years. So of course, the middle represents 50%, right? Which means that you have another 50% to split. So 25 goes here, and 25 will go there. That's 100 under the curve. And we want to know this value here and this value here. So you can call it x1, x2. It's up to you. So inverse norm of 0.25, right? Because I always want the value to the left, or the percentage to the left of the value I'm interested in. So this would be a 10, 1.15. We figure out what that is. You do another inverse norm. In this case, it's 25 and 50 to get you to here. Okay, so it's 75%. 10, 115. And there you have it. The first one gets you at 9.22 years. And the other one is 10.78 years. So I'll give you 1 mark for each entry there. And so this is the part right here that I want to teach you about today. So we're just going to omit this one, okay, for now. Or we'll do that later. So after I teach it to you today, you're going to try it here one last time before you submit it. So you're going to hold on to it. I'll give you a quick lesson. It doesn't take very long. And then you'll try that. And then we'll add it to our total after the lesson. Okay, so it'll be like open book. If you can do it open book, you're doing fine for today. So let's do the tally up until this point already, and then you'll just add whatever you got earlier. So 2, 4, 6, right? 7, 8, 9, 10. So up until this point, you have all the way, you go up to 10 here, not including question 4. So 10 and 8, right? 10 and 8. So we'll make this 18 for now. Just keep it at 18, and then we'll add our, we'll make that a bonus. How's that? So you have a score out of 18. Whatever you score on the last one, after my lesson, we add it as a bonus. So it won't affect you if you don't get it right. So hold on to it for now. Okay. Let's grab our